Good morning, everyone. I trust you are doing well today. Good afternoon, sorry. Today, I will introduce you my study, antimicrobial blue light emitting optical tympanostomy tube, an innovative approach to prevent tympanostomy tube otorrhea. First, I need to introduce you to the problem. Tympanostomy tube placement, it's the procedure indicated, surgical procedure indicated when you have otitis media with effusion, and this is the procedure most performed in kids. In kids. And the big concern about this is that the big concern about this procedure is that the kids will stay with this ear tube for longer, for months, to 6 to 1.5 years. And we can have a biofilm formation, since this effusion inside the middle ear can contain bacteria and can form the biofilm in this tube. Currently, we have available treatments that can be the optical ear drops, the antibiotic ear drops. But we have some limitation, like the bacterial resistant and also the antimicrobial can be inefficient against biofilm. We also have some another alternative, like ear tube coated with antimicrobial or impregnated with antimicrobial. But these also have some issue, how long this antimicrobial coating or impregnated will be working for this tube, and how long will prevent the biofilm formation. Then why not to use antimicrobial blue light? Our previous study proved that antimicrobial blue light is effective against a wide range of microorganisms, is compatible with conventional and non-conventional antimicrobial agents, and also until now we have no evidence of antimicrobial resistance. Then here we have our innovation, our optical tympanostomy tube. This tube is made by optical clear material that's approved by FDA. And we insert this instead to have the conventional ear tube, and we can illuminate the ear tube using an optical fiber. That the idea is to have something portable that the kid can have this, like a earbud, and can keep playing during the treatment. We can even do some at-home treatment. And until here, I can show you our proof of concept data. I can divide in 3 steps. The first step is the prototype development. We develop our optical TT prototype, first prototype, using a 3D printable material. It's a photopolymer similar to PMMA. We also are working in our device for illumination. Since we are doing our animal experiment in chinchilla, we need to have something with ear speculum longer. And here we have, Here we have something similar to an otoscope with a magnification lens that we can observe the ear tube and adjust the light to shine. For our in vitro experiment, we had 2 goals. The first goal was to compare our optical ear tube with the commercial one. The idea is not to have our tube with more bacteria growing than the commercial one. The second step was to evaluate the efficacy. We checked the 3 more important bacteria causing tympanostomy tube otorrhea, Staphylococcus aureus, Pseudomonas, and Haemophilus influenza. And after the efficacy in vitro, we test our efficacy in vivo, and we also check the safety in vivo using a chinchilla model. For our efficacy, we decided to test using Haemophilus influenza. The tube was the biofilm was pre-grown in this tube before the insertion to make sure that we would have biofilm before to start the treatment. And for the safety study, we performed the study with the tube without biofilm to not have the influence of bacteria causing inflammation in RTM. The first graph, we have, the bar graph. It's our biofilm formation in our tube, showing that our optical tube doesn't have more biofilm growth than the commercial one. And below we have our efficacy study, showing that in vitro, 30 joules was enough to kill more than 3 log of bacteria of Haemophilus and Pseudomonas strains. And for Staphylo, we need a little bit more, 60 joules to kill more than 3 logs. We also have our SEM image showing the morphological changes induced by antimicrobial blue light. On the left, we have the control group, and on the right, we have the ABL treated. Here we have our efficacy study. The bar graph shows the efficacy in vivo. After 30 minutes illumination, we have like 0 biofilm in these optical ear tubes in the chinchilla. On the left, we have our tympanostomy image showing the biofilm over showing the tube over the days. In the TM, we have no microscopic change in the TM over the days. And the histological image show the tympanic membrane over the days and over the treatment. Our data until now show that we have efficacy in vivo. The animals did not show discomfort during the treatment or between treatment. And we observed no microscope or histological change following antimicrobial light. So far, to wrap up our study, the idea of our optical tympanostomy tube is very innovative. It's promising. We have great results, but we still need to test more to be able to put this in the market. This is the idea, is to have something that we can treat kids. We still have a long way to work to refine the device and optimize our light delivery. Thanks so much. Thank you for my lab maters, and thank you for Dr. Pelton lab.